back again to Bawashil Electric. Once more, it is industrial automation. So allow me to introduce you to this concept of reverse and forward control. We are going to see a detailed preview of how a motor works in both directions. So before we start the real connection of reverse and forward, so I would like first of all to let you know this. When you have here 3 lines, and I have here a line, let me do like this. When I have here line 1, line 2 and line 3, then I have my motor, my 3-phase motor, that is it. Then we are going to make this connection. This one is an illustration before we go to the real wiring. How comes, or what is the logic behind the motor running in the reverse direction. So we are going to make a connection. So here you will see that line 1 is going to coil 1, that is U1. Line 2 is going to coil 2, that is V2. And line 3 is going to coil 3, that is W1. This is V1, W1. So when we try to run this motor, we shall see that the motor is running clockwise. The motor is running clockwise. Stop. Then we shall now change. I want you to view this very well. We shall get line 1. Now instead of taking it to V, we shall take it to W. Then we get line 2. Instead of taking it to W, we shall take it to V. Are you seeing? We have interchanged. Line 1 we have given it W, line 2, then line 3 we have given it V. So when we try to run this motor, we shall see that it has changed what? Direction. It is now running anti-clockwise. This logic is not that you only have to change line 2 and line 3, no. But for a 3-phase motor, when you interchange any two lines, then it's going to change the direction. When it was running clockwise and you interchange, it is going to go anti-clockwise. Or when it was running interclockwise and you interchange, it's going to run clockwise. So now let's see properly how we can do this logic without changing the power supplies or without doing a manual wiring. Like our wiring is going to do the mechanism by itself. So now we shall have here a power supply. Allow me have as usual line 1, line 2, line 3, neutral and earth. Then we are going to have a circuit breaker. Allow me have a 4-pole. Then we now, since our motor is going to run in 2 directions, we are going to have 2 different contactors. So we are going to have different contactors, but the motor will remain 1. So maybe we can also employ an overload. So those are the components we are going to use. So let's see how we connect. Remember, I've told you we are going to use direct on lines just. So we shall have the first direction allow me align this component very well. So from the breaker to the contactor, like that. So that one, assuming it's going to give us a clockwise rotation. So this contactor is going to be for clockwise, this contactor is going to be for anti-clockwise. So remember I said earlier that we interchange any two phases. So I'm going to have down the breaker. Remember always to get from down the breaker because it has to control everything here. We are going to get phase 1. It's going to remain consistent. Are you seeing? Then now for line 2 and line 3 we are going to interchange. We are going to get line 3 to make it line 2 here. Then we are going to get line 2 to make it line 3 here. Then the rest, line 1 shall go to line 1, line 2 shall go to line 2, and 3 shall go to 3. So that is it. When you follow, this is line 1, it is coming through contactor 2, it's going back to line 1. But when you come at line 2, is coming through contactor, is going here to line 3. Then when you come here to line 3, it's coming through the contactor, it is going to line 2. So this contactor interchanges the lines, interchanges 2 and 3, then it keeps 1 constant. As I told you, it is not that you only have to interchange line 1 and 2. No, I mean 2 and 3. But you can interchange 1 and 3, can interchange 1 and 2, can interchange 2 and 3. Any 2 changes the direction of rotation. But contactor 1, it keeps the line in their respective order. So that one is the power circuit is done. The power circuit is done. Maybe we can add on our protection, and that is the earth, which is going direct to the motor. So that is it. That is how we go about with the power circuit. That is the logic how we reverse the direction of the motor. So now when it comes to control, we have to design 2 different controls. We have to switch on contactor 1 independently in case we want clockwise rotation. Rather, we switch on contactor 2 separately in case we want anti-clockwise rotation. Take this into account. When you happen to switch on the 2 contactors at once, or any of the contactor to switch on when the other one is on, look at this. You see, this is line 1. When it gets back to line 1, it has no effect. But with a 3-phase power, should you make to connect line 2, it comes and joins the line 3. That will be like joining 2 lines together. That is a very horrible short circuit. Or line 3 here, it is coming and joining line 2. That is a horrible short circuit. That one can happen if this contactor is closed as well as this one is closed, which means power will be passing here as well as power is passing here. So the power which is coming directly from line 2 here, it is coming and meeting here the power which is coming directly to line 3. So you have joined line 2 and line 3. That will be a horrible circuit. It will be like joining a live and a neutral in a single phase circuit, but of course for 3 phase it is more terrible. So when we design our control circuit, make sure these contactors, when this one is on, this one is off. When this one is on, this one is off. That logic is called interlocking. Let us see as we design our control circuit how we come about with that one. So since I've said we have 2 different control circuits, they look different. I said they are different just because the starting mechanisms or the starting switches are the ones which are different, but the circuit is one with a singular power supply. As you can see, you can have here a control breaker, then we have the emergency, or we can have an overload contact. Then we shall have an emergency switch. Then we shall have a stop switch. These are timed contacts. So our normal push buttons are here. That's emergency, that is a stop. So for the stop, it is going to be a one stop because it has to stop everything. So we are going to have here a start. So this start is going to power on contactor 1. Then we are going to have another start which is going to power on contactor 2. So that means we shall have 2 different coils for contactor 1 and for contactor 2. But before we have the coils, we have some closed contacts. I will name them as we move on and we understand them properly. So then we can have 2 coils. So remember, it is a direct on line. We have to do the launching or self holding. So we shall have here a holding contact for contactor 1 and a holding contact for contactor 2. So now when we name this one, when we name our equipments, this one can be MCCB. Then this one is forward, we can name it FX. Are you seeing that's the forward contactor? Then this one reverse, you can name it RX. So here this one we name it MCB. I prefer uppercase, MCB. Then this one is overload, so it is F. Shall give it the same address. Then this one is emergency. This one is a stop. Then this one, it is a start for forward, that is FX. Then this one is a self-holding for forward, still FX. So to differentiate these two, before we start, this one is FX switch. FX switch. Then this one is a reverse, that is RX switch. Hope we are still together. So this one, before I name this contact, this one is a coil for forward, that is FX, and this one is a coil for reverse, that is RX. So this one is a contact for RX, this one is a contact for FX. So now this one is a normally closed of this contactor or this coil. So this one is RX. And this one is a normally closed for this one. So this one is FX. So now these two contacts here are the ones that provide what we call an interlock. They don't allow this coil to go on when this one is on, or this one to go on when this one is on. It must be one at a go. Let's do the wiring and we see how it comes about to happen. So shall have here our phase wire, connect systematically. So here we shall just have a go through like that. Then we have this here also shall have no, here this one stops here, this one stops here. So our phasing is done, so we are remaining with the neutral. Let me get a neutral cable here. So that is our neutral cable. So let me give our control breaker power from the main breaker, or we can get it right away from here. So this is our neutral. So we are going to do our simulation. I have modified a little here power supply just for neatness. I've got it from here just to make it look neat. So we are going to play our simulation. Then we power on the power breaker, then you also power on the control breaker. So when we switch on forward, you will see that the motor is running in clockwise direction. And since this contact is for this one, it is self-holding, then here this contact is for this coil here. It has opened. So when it opens, however much you switch on this other direction, it can't turn on because this contact here is open. That is what we call interlock. What do you have to do is first to stop. So when you stop, it goes off and it closes again. So now when you switch on anti-clockwise, you see our motor is now running in the anti-clockwise direction. The same way this coil here opens, it is contact which is on this line here. So however much you switch on the clockwise rotation, it does not go on until also you press stop. So briefly, that is how we change or we control the direction of rotation of a motor. But this kind of starting, it is just a direct on line. This is one direct on line and this is another direct on line merged together to form a forward and reverse. This one controls this contactor for clockwise, then this one controls this contactor for anti-clockwise. Then in our next video, we are going to see the arrangement of the real components, how we do a forward and reverse starting. This has been a circuit diagram. Thanks for watching. Check in the description below for a link to the next video where we are connecting the real components, the real contactors, the real motor. This is a guide circuit. Thanks for watching. See you when you see me.